Hello, my name is Sherman Coleman, and I'm going to show you how to balance an equation today. So, first thing we need to talk about is why do we need to balance an equation? And if we look at our equation here, it says N2 plus H2 yields NH3. And so, when you look at this with the naked eye, nothing seems to be wrong. But if you'll see here, there's two atoms of nitrogen over here, but there's only one over here. So how do you have two of something and end up with one? How does that happen? Um, so this is an equation that actually does happen in real life. It just needs to be balanced. So before we balance the equation, there's a couple of things that we need to talk about first that will help us and not allow us to make any mistakes. So first thing we need to understand is that everything to the left of the arrow here, which means the yield sign, is called the reactant side. And everything to the right is called the product side. The reactant is what you have before the reaction starts, and the product is what you have after the reaction happens. So the same number of atoms on each element have to be equal on both sides. So you have one atom on the reactant, you have to have one on the product. If you have three on the reactant, you have to have three on the product. When you don't have that, that means your equation is imbalanced. So the second thing that's important to know is that we balance equations by changing or adding coefficients, not subscripts. Coefficients can be changed. We can manipulate them and do whatever we want with them. We cannot change the subscripts. The subscripts are these small letters here that are underneath each atom. And they serve as a multiplier. So when you see N2 right here, that's telling you that there's two atoms of nitrogen that are bonded together. Here, this 2 says that there's two atoms of hydrogen that are bonded together. And this compound says it has three hydrogens that's bonded to a nitrogen. We cannot change those. So one of the biggest mistakes that's made when balancing equations that can lead you down a wrong path is trying to change these subscripts. Don't ever do that. We only balance equations by adding numbers in these blanks here. And these are where coefficients go. And these are multipliers. So for example, if I put a 4 here, then that means that there's 4 times 2, in other words, 6 nitrogens. Or if I put a 7 here, that means this is 7 times 2, or 14 hydrogens. And of course here, we don't see anything by the nitrogen. That means it's an assumed 1. So if I put a 4 here, it's 4 times 1, so it's going to give us 4 nitrogens. But it would give us 4 times 3, 12 hydrogens. All right, so with that being said, we're going to balance this equation. So balancing an equation is 3 simple steps. The first step is we count each type of atom in the reactant and the product. And we want to see if the numbers are the same. So let's do that. So if we go here to our reactant side first, we see that there are 2 nitrogens and 2 hydrogens. And so if we go on our product side, we will see that there's one nitrogen, and there are 3 hydrogens. So now that we have done step 1, we can clearly see that this equation is not balanced. So for the nitrogen, there is 2 on the reactant, but only 1 on the product. And for hydrogen, there's 2 in the reactant and 3 on the product. And so now we have to go to step 2. And step 2 is basically balancing all the elements by changing the coefficients. So here we have nitrogen and we have hydrogen that are unbalanced. So the question is, well, which one are we going to change first? And the answer is, you're going to add a coefficient to the simplest one. And so this takes a little observation on our part. So let's look at it. So we know here that there's 2 nitrogens here and 1 nitrogen here. So we have to add something here to change the number of nitrogens. And this is the only place where we can add nitrogen. So if we ever want to balance nitrogen, we have to use this blank right here. When we look at hydrogen, we see that, and we also see there's another thing that we should actually talk about right now. When we put a number here, everything gets multiplied by this number. So not only are we changing the nitrogen, but we're changing the hydrogen. And so with that being said, if you look at the hydrogens, we'd have to change something here, right? But by doing that, we always have to change something over here too. So for example, we put a 2 here, that's gonna make it 4. But now we have to somehow make this 4. And see, you start to see the kind of the game you start to go into. And so the simpler one to change in this case is the nitrogen. So let's change the nitrogen. So there's 2 nitrogens on the reactant side. So we have to put a number in this blank that's going to make nitrogen equal to 2. And we know that this subscript for nitrogen is 1. So what times 1 equals 2? And we know that. We know that 2 times 1 is equal to 2. So we're going to change this coefficient to 2. And now we have 2 NH3. So now 2 times 1 is 2. So now we're going to change our number of nitrogens on the product side to 2, but also we're changing the hydrogens. So now we have 2 times 3, which is equal to 6. All right, so now we successfully balanced the nitrogens. And as you can see, step 3 is repeat steps 1 and 2 until your equation is balanced. So we've balanced the nitrogens. Now we're going to balance the hydrogens. So we know that the hydrogens need to be 6 on the reacting side. And lucky for us, this is the only place where we can put a number to change hydrogens. So we know that this is the blank that we're going to use. So we have 2. So what number multiplied by 2 is going to give us 6? And we know this already. We know that 3 times 2 is equal to 6. So we're going to change that to a 3. So when we change this to a 3, we now have 3 times 2. In other words, 6 hydrogens. So now we can see that we have nitrogens, 2 nitrogens on the reactant and the product side, and 6 hydrogens on the reactant and product side. Our equation is now balanced. So our balanced equation is N2 plus 3H2 yields 2NH3. So those are the steps to balancing equations.